Okay, so just a short explanation because we did it something wrongly with the statistics. I was a bit confused from the values here, and because it's very low, and I was not much sure what happened, so I had to check it. But our discussion about units and so will continue very soon. So we have to do the statistic again, but with different layer. I was thinking that what we call here watershed boundary, that is the polygon of the catchment, but it's not. It's only the line of I just see the message from Ryu. Sorry, I'm very sad about the situation that you cannot hear me. You can have you tried just cancel the phone call? Maybe turn on. Yeah, he's not hearing me. I just write him the message, try to so I hope that the situation with Ryu will be better soon. So it's our watershed boundary is only the line around the watershed. So when we did zonal statistic, we will need it very soon for other evaluation. But it's only the line. So the average value is not average value on the whole watershed, but it's average value on the line of watershed boundary. What we need right now, and we don't have it in our project yet, we need to, yeah, please follow me with saving the project, just to be sure, and we had to did it in the beginning. So let's save as the project in our home folder, and we use 07 like our 7th class. So I change the name, like save it in new version. That's the thing we usually do first, but I just forgot it. And what we need right now is to check in our catalog, in our database. I just toggle this content panel to view like this, and I can find somewhere at the end layer which is called watershed. Okay, thank you very much. Thank you very much. I just start the sharing screen. Good. Right now you can see it. Thank for your message. In the video, all I did is over there. So again, what I did right now. So there is watershed boundary. Great, Ryu can hear me again as well. Great. So for all of you right now, so mistake what I did once more, in our zonal statistic table, the values are lower than I expected, and the reason is that we did the evaluation on watershed boundary only. It's the line around the watershed. So our mean value of soil loss, it's only on the watershed boundary, not in the area of watershed. What we need right now is look into catalog in our database and to find at the end of our layers it's watershed, layer called watershed. When you add it into project, just drag it in, you can see the polygon right now. Polygon covers full watershed. I can check it in the properties in sources. When I check the properties of watershed class, watershed layer, I can see its polygon, and our previous, which is called watershed boundary, its future, which is named watershed line, and its geometry type line. So that's the difference. So we can just leave it here like it is, or we can change the symbology. We can change the symbology somehow. Or just don't change the symbology right now, because we have a line for our maps, and just leave this watershed layer over here, but we don't have to colorize it. And then let's come, all of you come in geoprocessing options. So open geoprocessing option, and we have to turn on checkbox to be able to override outputs of geoprocessing operations, because we use from results our previous calculation and we just did it again. So override the outputs of geoprocessing operations. Okay, and let's open the results. If you have it here on left side, let's open it here. If you don't have it, it can be found in geoprocessing results. So let's open results, and in current session you can open directly Zonal Statistics table, the last tool and only one tool we use today. Only thing we need to change is the first line, input feature zone data, and we change it to watershed. And sure, we have to change the second line about zone field, because the table does not contain the same columns like previous. There is a question if I can repeat it. Sure, I can repeat it. You mean probably adding the layer? Yeah, sure. So let's look on my screen. I open the catalog, and you probably can see when you open your catalog for the first time, you can see the view like this. Your home folder is over here. With the plus I can open it. What I'm using mostly, it's to change the view of content panel. So I use this icon to have it the tree of folders up and the detail of chosen folder down. So when I choose my geodatabase, the content of geodatabase and all layers are visible downstairs. So I drag down and find out in my database, I find out a layer which is called watershed, and I just take it and drag it into the project. You can see this small plus close to my cursor. When I drag it there, it opens and adds layer into the project. I just remove it because I already have one there. And then I opened, just once more, I show you geoprocessing results, and double click on the name of the tool. I can open the tool from previous session. So change the first and second row. So we have to use watershed, which is the polygon, and zone field, we use object ID. Still, we would like to do the statistic for the same raster, and we can use the same name. If you see here red cross, it means that you did not allow in geoprocessing option overwriting the outputs. So better is to use overwriting, and then you can choose the same name and then run it. Okay, our table is ready. Let's switch table of contents, the list of layers, to list by source to see our tables. And right now I open it. Yeah, it looks much better right now. So as you can see right now, our average soil loss is 4.24, let's say. 4.24 tons per hectare per year. Because result from USLE, Universal Soil Loss Equation, is average total average soil loss, long-term soil loss in tons per hectare per year. So when we do the zonal statistic of mean, of average, is the same unit. And right now there is a question: what is the total soil loss? So the same way like David suggested was to take this summary. It's the summary of all our pixels, which is partly good, but we are missing the resolution information, because it's not the summary of values for hectare. Because if you summarize units in hectares, each hectare you count it, the result will be in tons per year because of summary in hectares. But our resolution is 5 to 5 meters. So we don't have hectare, we have 25. We have 5 to 5 meters, which is 25 square meters, and 1 hectare is 100 times 100 meter. Right? So if we would like to use the value over here for 5, 6, or I can just use calculator over here directly. When I use directly this value, I have to choose the right resolution. So our area, it's much smaller than 1 hectare. So you know how to do it. You are able right now to tell me what is our total soil loss. Okay, so I show you. So if you would like to use this value, this summary, we have to divide it by 100 and 100, 10,000. So it will be in units of square meters, and multiply by 5 and 5, which is our resolution, and this is the result. So our total soil loss is over here. I can maybe just to note it. Yeah, I can use total soil loss watershed is over here. I do tons per year. I can show you the another way of calculation over here. If I just leave it over here with this snipping tool to compare it, you know, right here we have column of area and we have column of mean soil loss. So when I choose soil loss, I use the calculator. So mean soil loss multiply by the area. So I copy the area over here. So mean soil loss multiply by area, divide it by 10,000, because of 100 to 100 meters is 1 hectare. It's the same right here. You can just compare it. Sure, not for the decimal places till the third one, but it's the comparable. So two ways of evaluation. So the mean value is already our number because it's in tons per hectare per year when whole calculation was. Second, if we are interested in total value, we can use the summary, but we have to just change the resolution for the correct one. And third option is to use area and the mean and multiply it, and in the same time change the resolution to hectares to have correct number. Is it understandable? If yes, we can continue with evaluation there. So I just switch into syllabus to check what we have here. So we have average and total soil loss per watershed. I can just type it over here. Then the average one is this. 4 tons per hectare per year. Good. I see it. Okay, and what next? Right now we have idea how the situation looks like on the whole watershed. It's the very much helpful information. Right now, for sure, we have one catchment. In case that you have another catchment nearby, let's say very closely over here, 1, 2, 3, 4 catchments, and you would like to just compare briefly what is the situation about soil loss. So these two values can give you very helpful information. You just compare total soil loss per watershed or average soil loss on the watershed, and you have briefly view what is the status of the catchment, which catchments is better, which is worse, and how does it look like. But we are interested in more here. We are interested in transport of the sediment. I can turn on our not parcels but land use. I just turn off soil loss right now, and you can look on my screen what I have here. Okay, that's the land use. Okay, that's the land use. Why not? Yeah. So probably on the base map will be visible much better. So you can see that there is a river net starting two parts. You see the reservoir we are interested in at the end. There is one main stream, Prushanka, going up north somewhere here started, and there is the another one which is coming over here. We calculated soil loss, but it means that the number of sediment of soil which is transported, which is loses, is transported from one place to another. But it does not mean that this value, total soil loss, really reach the reservoir. It depends on a couple of other things, and there is a very easy way how to estimate it. Let's look on my screen in syllabus. The method is called sediment delivery ratio, SDR, worldwide used method for estimation of amount of sediment which is really transported by the river net and leaving the outlet, or if there is a reservoir, it means reaching the reservoirs. So, which is actually our case. As you can see, for the equation, so SDR means sediment yield divided total soil loss. Total soil loss is one parameter we already know, and we have to and we are interested in sediment yield, which is the amount reaching the reaching the reservoirs. It means over here that sediment yield, we have to multiply our total soil loss by SDR. And how to estimate SDR? SDR is the function of parameters. Function of watershed area somehow depends on how large the area is. Another is relief ratio. So it's something about altitude, let's say, about altitude at the top, average altitude, in the same time depends on outlet altitude, and about maximal stream length. I will show you and explain very soon. And the last parameter is CN value. I don't know if you already heard about SCS curve number method. It depends on land use type, let's say. In the same time, it depends on soil properties, let's say, and it describes how the situation looks like about the direct outflow, let's say. So if I show it when I am right now talking about CN values, if you are interested in the method in detail, when you open Google and you type CN curve number, even on Wikipedia there is written about the method done by USDA, National Resources Conservation Service, long time ago, but is worldwide known method how to estimate it. And even you can find the tables for different land uses, and so that's actually the thing we already prepared for you in the table. You can see it over here downstairs in the table here. So for our arable land, the CN value will be 81, for forest 65, and so for water bodies 100. It means for water bodies, reservoirs, rivers, 100%, let's say, is direct outflow from the rainfall. So when the rainfall comes, all the intensity of the rainfall is directly flowing out. From water bodies 100, from arable land 81%, it's leaving the place. From from the roads 90%, and so that's not exactly direct outflow, but you can just try to imagine like this. So with the parameters CN, relief ratio, and watershed area, we are able to estimate SDR and say the amount of the sediment which is reaching the rivers and which is reaching the water reservoirs. So let's switch into our project and start to evaluate. Do you know what is the watershed area? You probably don't have the value yet. So let's open our attribute table of layer watershed, of the polygon shape of our watershed, and we can find here directly, because we are in database, we can find directly shape area calculated in square meters. So I can just copy it and just use my notes here and just type it that my area is over here in square meters. Okay. So it's very easy how to handle. Just to have the layer in our database and we can compute it. I can show you one more handy thing how to calculate area. If you open the layer and you can just would like to check the value, you can use this option and add field into the table. So I open the table of watershed, of polygon of watershed. Right now I'm adding the field. So left top corner of the table, add field. I just name it area. Sorry, I just switched the screen. And you can see it in syllabus that watershed area is in square kilometers. So I'm interested in area in kilometers square. So for this reason I named the column area square kilometers. And very important to change type, not a short integer, because it's value with no decimal places. I have to choose double format. So new field, area square kilometers, type double, press OK. And then right click on the name of the column and use calculate geometry. So again, when I have new column, right click, calculate geometry. There is a message that you are editing and you are not in editing mode. Just press OK. Sure, we know about it. We don't have coordinate system. Okay. Just a second. Yeah, we are using this. Okay. I'm just thinking about the coordinate system of the layer, because there is not defined coordinate system of the layer. Maybe we can use it. So just to show you, if I'm calculating geometry right now, I can see that there is unknown geometry, unknown coordinate system. I would like to define it. So please open search window of our tools and find define projection in data management. Yeah. So find tool which is called define projection, data management. And then choose the layer, watershed, and then choose coordinate system. The code is 5514, which is Křovák East North. So I choose it. Yeah. And then press OK. It just define our projection, and if successful, yeah. If you are successful, you can calculate geometry of our field, and right now you can see that you are able to choose it. Right now it's visible that our coordinate system is Křovák East North, and you can use the units, for example square kilometers we are interested in, and then press OK. Sure, just yes the message again, and that's our result. For sure, you can see it's the same lake shape area over here. Not so many decimal places, but it's the same value. So, once more, just to remind it, I open the table of watershed polygon, I add field, I choose the type double, I use name area square kilometers, then I realize that I have to define projection that was running of two defined projection. I define projection of the watershed to Křovák East North, which is the code 5514. And then I was able to use right click button on the name of the column, calculate geometry, all the time say yes to the question about editing mode, choose the units square kilometers and press OK to calculate it. So I just put the note over here in square kilometers, just for me, in syllabus. Okay, it was about the area. So let's come for another one, relief ratio. It's something which is called average divide altitude and the altitude of the outlet divided by maximum stream length. So let's take care about altitudes right now, and in the method of SDR we are interested about altitude of the boundary because it tells us something about morphology of the catchment. So not the statistic of whole catchment, but the statistic of the boundary of the line over here only. We use our DMR4G and watershed boundary, and we do the zonal statistic. So I just run the zonal statistic as table. Again, the same way like we did before. So I run the tool, and right now is the time that we really use watershed boundary, only the line of boundary. So watershed boundary, and our value raster, it's DMR4G fill. So digital elevation model, and we call it zonal statistic boundary, zonal ST, zonal statistic boundary altitude. And we use statistic type all, the same like previous. I run the statistic. And result is over here. So right now I can find, I'm interested in average divide altitude. Can just use it over here. So my average divide, yeah, capture the window of the tool, sure, I can do it. So yeah, I send it in messages. So my average altitude is over here. So it's this number. Minus watershed outlet altitude, which is exactly the minimum value. So I can use it. And right now there is a question, what is maximum stream length? Maximal stream length. It's the length of the stream, and we really have to measure it by the measure tool. It's the easiest and quickest way how to do it. Okay, there are tools how to estimate this by GIS tools, GIS hydrology tools, but it's for longer evaluation. So right now, maximum stream length means from the outlet through the river net up to the top of the hill. So we are not ending over here, but we have to go on the top of the hill. So we are coming, let's say, over here. Yeah, somewhere. Maybe over here at the top. So like this. I can use the measure tool and just measure it very roughly. You can do the same. So from the outlet, just trace the stream length. And you can tell me the value you will estimate. Oh no, I just did it wrong. I accidentally double click over there. You don't have to be very much precise. But let's try the best you can. You know, I'm in scale 1 to 20,000, and you can see what I did. Yeah, and over here I just try to follow the, let's say, the longest way to the top, which can be over here, probably at the top of the hill. So I have something like 10 kilometers. So if we are talking about radial kilometers, so the radius ratio is on the top, the altitude in meters, and downstairs stream length in kilometers. So in kilometers I have 10. You probably will have something like 9 point something or 10 point something. So we are ready to estimate our SDR, almost. What we are missing right now is CN values. Ensure to apply it in this equation, which is not easy, the equation, but I have something prepared for you. So let's use we will dissolve the land use. Okay. I just find out what is in our land use. In our land use table. Okay. So let's do it. So if you are ready, let's come into our project, back to our project, and let's use the tool which is called Dissolve. Dissolve in data management. As you can see in the syllabus, there are a couple of categories of land use we are using: arable land, forest, gardens, grassland, and so. And there is exactly one CN value for each category. If I open my land use table, you can see there is currently 1,495 parcels, let's say. But we are interested in categories. So we can dissolve it, just merge it together based on categories to have it only, I don't know how many, 3, 6, 9, 10 categories, and then easily type in the CN values there. So let's use the dissolve of the land use 2019, and result will be land use 2019 dissolve, and dissolve based on land use. So I have to check the land use field, and what I have to change it, don't forget, it's yeah, that's what we need. That's okay. I was just checking if create multi-part feature is turned on, which is correct. So the tool will be like this. I can just copy it for you as well, and I can run the tool. Great. If I open the table of dissolved land use, you can see exactly the value. I just did it maybe we should do it. We can run it again. We should do it with LU label field. You can see on my screen that I did it by land use, but you can see only the shortage A, ZP, C, KP, and so. If we did it the same by LU label, the result will be the same, but in the table we will see the full name of category. So I just run it again, dissolve, and I can check LU label instead of land use. I use the same name, it just override the output. Yeah, that's the way I am right now successful and happy about. So I can send you the second image, and we are right now able to add new field over here. So again, the same way like we did previously in land use 2019 dissolve, we add field. We use integer because we are using value with no decimal places, and we can call it cn, just the cn, and we can leave short integer here. So I can just send it to you. So add a cn value, and right now it's written in syllabus. I'm just trying to follow the syllabus as much as possible for you to be able to follow as well. We start editing and add there the values. So I just show the table over here. So if I'm in the table and I press Ctrl Ctrl plus E, it start editing. Ctrl E, it start editing. You can see the right now you are able to edit the values, and I can type it. Arable is 81, forest 65, garden 76, grassland 70, high vegetation 65, orchards 65, paved surface 92, small roads 90, vineyard 81, water bodies 100. And when I am done, I just press the same Ctrl E, and question is, do you want to save your edits? Sure, yes. And there is cn values in the table. So once more, I have opened land use 2019 dissolve. In the table I press Ctrl E. I type the cn values like in the syllabus table, and then press Ctrl E again and save it, the edits. So right now I have cn values of my land use. What we can do right now, and maybe I will be quite fast someone cannot find land use dissolve. If you don't have it, you have to create it. That's the tool I did, which is called dissolve. So I run the tool dissolve. It's one screen in our chat. You can find it there. So based on land use 2019, output is land use 2019 dissolve. Question is where you stored. So let's check in the results. If you open it again, check if you have the correct address into database, if you have a correct name, and if you did it right, and you still don't see it in your project, just check it in catalog in your database if you have it over there. I have it over there. Great. So right now I have CN values. What I can do right now, I do couple of quick things in 5 minutes to finish our SDR, and then I'm able to explain it once more, or you will see in the video, and for sure you can just talk a bit more about SDR next week. And so right now I can just show you, and maybe the best will be if you next 5 minutes you will look on my screen. So I just will show you what CN looks like if I change the symbology of my land use dissolve. I choose quantities, graduated colors. I choose the CN, and then I apply it. Right now you can see something which can be explained like direct outflow. So more dark color means more direct outflow based on CN values. So it is the visualization of the land, and what we are interested in right now is to check the mean value of CN values. So we will rasterize it and then do the zonal statistic. So I will do it very fast. So have we already used zonal rasterizing? I just checked. Yeah, I have it. 3 weeks ago I have it in my results. I'm using it from results because a couple of things it's already set up, but we can use it as a new tool as well, but it's not a problem. But I'm just checking if we was working with it already. So I can choose the already predefined. Right now we are trying to rasterize land use dissolve based on CN value. It's called CN raster, and the cell size will be still the same, 5 meters. So I rasterize it, and then I use zonal statistics table for whole watershed. So zonal statistics table, watershed, right now I'm interested in CN raster, and I can name it CN watershed. And just run it. And this is our result of mean value of CN. So I just switch in syllabus. And I just edit. I will capture it for you in a couple of minutes. I just would like to show you the calculation to the end, and then I will say it again and capture the tools. So average CN is over here. So right now, if I'm correct, I already have all my inputs for SDR, and I can save for you I can just delete over here. SDR, I leave it. So it's just predefined document. I will prepare for you. So SDR, well, we already had there, but never mind. 2020 SDR. So if I use this both, so if you remember, just zoom it out just a bit, still not the best, but much better. So there is an Excel sheet. You can probably find it in your data. I just deleted all the inputs to be able to to fill it in. So I can just copy watershed area over here, relief ratio. I can just type it exactly. I have here relief ratio. Oh no, yeah, it's a bit confusing. Just edit over here. So this minus this divided by 10. That's my relief ratio. CN value, it's over here. And very important is the A watershed, so total soil loss, which we calculated over here. I just do it like this. So let's look on my screen. What is my calculation? So I filled here watershed area, all the inputs, watershed area, relief ratio, and CN average. And this is the application of the equation. So just the same equation you have in syllabus or directly in Excel sheet. And it says us that SDR, sediment delivery ratio, is 0.42. It means that on only 40% approximately. Just over here. No, that's about the reservoir. We will talk more about this. Yeah, it means that only around 40%, 42% of loose soil, of eroded soil, will reach the river net. So most of the sediment, which is somehow eroded, 60% approximately, is really staying on the place directly in the field, and it's not contributing into the river, it's not transported downstairs to reservoir. So that's our result. We will continue with explanation about the reservoir a bit later, so just leave it like this, that we know that our soil loss in the catchment is 11,400, but the sediment yield, it means the amount of sediment which is transported into the rivers and potentially into reservoir, it's lower than 5,000 tons per year. Yeah, let's say that's over of our lecture, and I can just explain to you everything you need more. Just don't forget at the end, save your project and leave it after.